Hello everyone and welcome to session 2 of our prompt engineering course. So, let's begin our journey into advanced prompting. Consider the question shown on this slide. At first glance, some people may conclude that if some flowers fade quickly, then some roses must also fade quickly. However, this conclusion is not logically guaranteed. Chain of thought prompting encourages AI to reason through the problem step by step before producing an answer. Instead of jumping directly to a conclusion, the AI evaluates each logical relationship carefully. This often improves performance on reasoning tasks, mathematics, planning, and problem solving. But why is chain of thought prompting necessary in the first place? Some questions are straightforward. For example, asking for the capital of India requires factual recall. However, reasoning questions involve multiple logical steps. The AI must analyze information, evaluate relationships, and draw conclusions. Chain of thought prompting guides the model through this reasoning process. By encouraging step by step thinking, we often obtain more accurate and reliable answers. Transition. Let's look at some example prompts. Here we see two examples. The first is a logical reasoning question involving flowers and roses. The second involves calculating profit, taxes, and net gains. Both problems require intermediate reasoning steps. Without structured thinking, the model may make mistakes. Chain of thought prompting helps the AI systematically solve these problems before producing a final answer. One of the simplest forms of this technique is called zero-shot chain of thought. Zero-shot chain of thought is remarkably simple. All we do is add a phrase such as, "Let's think step by step." This small instruction encourages the model to perform structured reasoning. Research has shown that this simple addition can significantly improve performance on many reasoning tasks. It's one of the easiest and most effective prompt engineering techniques available. An even more powerful approach is few-shot chain of thought. In few-shot chain of thought prompting, we provide examples before asking the target question. Each example demonstrates how the reasoning process should be performed. The AI observes the pattern and then applies the same reasoning style to the new problem. This approach often produces more accurate and consistent results than zero-shot prompting, especially for complex tasks. Modern reasoning models take this concept even further. Modern reasoning-focused AI models often perform chain-of-thought reasoning automatically. Even when users ask only for the final answer, these models internally analyze the problem step by step. The reasoning process occurs behind the scenes. The user sees only the final result, but the model has already performed extensive internal analysis. This capability is one reason why reasoning models perform exceptionally well on complex tasks. Researchers have studied these internal reasoning processes extensively. This slide references a research paper exploring how reasoning models think and solve problems. Researchers continue to investigate the internal mechanisms behind AI reasoning. Understanding these processes helps us build better models and develop more effective prompting strategies. As prompt engineers, we don't need to understand every mathematical detail, but it's important to know that structured reasoning plays a critical role in AI performance. So, do we always need chain of thought prompting? The answer depends on the model. For advanced reasoning models, explicit chain of thought prompting is often unnecessary because the model already performs reasoning internally. However, for smaller models, local models, or non-reasoning models, chain of thought prompting can significantly improve results. Understanding your model's capabilities helps you choose the appropriate prompting strategy. Let's now look at an automated version of this technique. Automatic chain of thought builds on the few-shot concept. Instead of manually providing examples, the system automatically retrieves relevant examples from a repository. These examples guide the reasoning process and help the model solve new problems more effectively. This approach combines the power of example-based learning with automation, making it highly scalable for real-world applications. In the next section, we'll continue exploring advanced prompting frameworks and techniques. In the previous slides, we learned about zero-shot and few-shot chain of thought prompting. But manually providing examples every time can be difficult. That's where automatic chain of thought or automatic CoT comes in. Instead of writing examples ourselves, we first create a large repository of solved examples. These examples are then grouped into different clusters based on their type, difficulty, or reasoning pattern. When a new problem arrives, the system automatically selects representative examples from different clusters and includes them in the prompt. The key idea is diversity. As shown in the diagram, examples are chosen from multiple clusters such as cluster 1, cluster 2, cluster 3, and so on. This variety helps the AI learn different reasoning patterns and significantly improves its problem-solving performance. In simple terms, automatic CoT automatically finds the best reasoning examples so the model can think more effectively without requiring manual effort from the user. Let's understand how automatic chain of thought works in practice. Instead of manually writing reasoning examples every time, a collection of high-quality examples is stored in a repository. When a new question arrives, the system automatically selects the most relevant examples and includes them in the prompt. This allows the AI model to learn from previous reasoning patterns and apply them to the current problem. The result is improved reasoning accuracy while reducing manual prompt engineering effort. This approach is especially useful in enterprise applications where thousands of similar queries are processed daily. Now let's move beyond reasoning and explore another important prompting strategy: